Hello, students. This is a very interesting question that was asked today, and I thought I would post the solution through this video. So you have, let's read it first. Let AB be less than -1 and C be less than B. So first of all, here you're saying that B is less than -1, right? And then C is less than B. So what you're saying is C is less than B, which is less than -1. So C is an even smaller value. Then it says, assume that ABC is a critical point of the function f of x, y, and z. And then it says, assume the Hessian matrix is H of f, x, y, z, which is such and such. So remember the Hessian matrix is of this form. And when you plug in the critical point A, B, and C in place of x, y, and z, what you get is this matrix that they've shown you. Then they say, determine whether f has a relative minima, maxima, or a saddle point at the critical point A, B, and C. Now you form the submatrix just as we have done in class several times. So you have A1, which is AB, just the first, element, first row and first column, which is AB. And then you find the determinant of this matrix. So D1 is the determinant of A1, and that is AB. Now, what would be the sign of AB? So here you see that A is negative and so is B. So when they multiply, they're going to give you a positive value. Now let's talk about the determinant of A2. So D2 is going to be the determinant of A2, which is A squared B squared minus AB. If you could take AB common, you'll have AB minus 1, right? Now, as we discussed here, that AB, because A is negative and B is negative, so AB will be positive. Now, what about this thing over here that AB is this AB minus 1? So notice that A and B are both less than -1. For instance, A could be minus 1.1 and B could be minus 1.1, right? And then when you multiply them, then AB will be a positive value and a positive value that is greater than 1, right? So you could choose any value very, very close to -1 and see that when you multiply A and B, they will be positive. Yeah, for sure, A and B will be positive, but they will also be greater than -1. So AB minus 1 is also positive. If you did not get this point, please write to me and I will try to explain to you in class or through email. So AB minus 1 is positive. So when you multiply two positives, then you get that D2 is also positive. Now let's talk about the determinant of A3, which is D3. And that comes out to be AB times AB into minus C cubed, which is say A minus ABC cubed, and then minus 0. So that's it. And then minus B times, and then you have A times minus C cubed. So you say minus AC cubed minus 0, and then you have plus 0 times 0 minus 0. So we don't write that. And this gives you, if I try to, open this up a little bit, it's minus A squared, B squared, C cubed, and then plus from here, A, B, and C cube. So I try to take A, B, and C cube common. So I have A, B, C cube taken common. And then I have A minus A, B, and then plus 1, right? Or I could say A, B, C cube into 1 minus AB, right? Now, A and B were a negative, so when you multiply two negatives, then you get a positive. So this is a positive multiplied with C cubed. C is a negative. So positive in C cubed will be a negative value again, right? So positive into negative, this overall, this AB and C cubed give you a negative value. Here, I already discussed with you that if A is less than -1 and B is less than -1, then AB will be greater than 1. AB will be positive and AB will be greater than 1. So here you have 1 minus AB, which is going to be a negative value. So then you have negative into negative. So overall, the answer is going to be positive. What happens? So we have done much theory in class. So what happens in this case when D1 is greater than 0 and D2 is greater than 0 and D3 is greater than 0? So you conclude that your function f has a minimum at the critical point A, B, C. I hope that helps. Take care of yourselves. Thank you.